So we're going to jump into finished patterns. We're going to jump into functions. All right, so functions are very, very important. They appear in paper 1. All right, so we're going to look at linear functions first of all, and then we are going to look at quadratic functions. So, first things first. A function is a relation which has only one output for every input. What that means is, what happens with a function is, we take an input, so we take a number, we put it in through a function, and we get out a different number. Is that right? So that's what a function is. A function is where we take a number, we put it through a function, so we put it through something, and we get out a different number. Okay? So, our input, so the list of these numbers, this is 1 is an input, 3 will be an input, and 5 will be an input. Is that okay? They are referred to as our domain. So the list of all our inputs, that's called our domain. So it's a set of inputs, and that is asked, believe it or not, it has been asked. That's known as our domain. So all our inputs put together are called our domain. What we get out, our outputs together, is called our range. So that's what you have to remember. Don't worry about codomain from spending. Domain is all our inputs. Our range is all our outputs. Is that okay? So, we won't do that one just yet. This is our function. So this is a linear function. Our function is 2x minus 4. And we want to see that this is our domain. What did I say our domain was? Our x values, our inputs, isn't it? So these are all our inputs. So we want to see, when we put our inputs into our function, what are we going to get for our range? So we do that via a table. Here is x, our inputs. This is our function, 2x minus 4. And this is our outputs. Is that okay? So our inputs are minus 2, minus 1, 0, 1, and 2. Minus 2, minus 1, 0, 1, and 2. Our function is 2x minus 4. So we're going to change our x to our input. Because it's 2x minus 4, or x is our input. Does that make sense? So instead of x, we're going to play what? Minus 2, exactly. So it's going to be 2 times minus 2 minus 4. 2 times minus 2 minus 4? Minus 8. Alright, minus 8. So, minus 1 is next. We're going to go 2 times minus 1 minus 4? Minus 6. Good girl, Emer. 2 times 0 minus 4. So give her a chance, Emer. Good girl, minus 4. Julianne. 2 times 1 minus 4? Minus 2. And 2 times 2 minus 4 is 0. So, here's all our inputs. What's another name for all of our inputs put together, guys? Domain. So, here is all our outputs. What's another name for our outputs put together? Range. Exactly. So, and they map each other like this. Minus 2 maps over to minus 8. Minus 1 maps over to minus 6. 0 to minus 4. 1 to minus 2. And 2 to 0. So they map onto each other. Because we've got our inputs, we put it in through our function, and we came out with our outputs. Is that okay? Right, I want you to do the exact same with the following. So our inputs are going to be from minus 3 to 4. I'll go from minus 3 to 2. Our function is going to be 3x plus 1. And I want you to do a table. So I want you to get me an input through your function and get an output. So I want you to do a table exactly like that's on there. We all done? Right. Let's look at it so. Our inputs is -3, -2, -1, 0, 1, and 2. Our function is 3x plus 1. And then our outputs are going to be over here. So, our first one is 3 times -3 plus 1, which is what, Julian? -8. Emer, 3 times -2 plus 1, -5. 3 times -1 plus 1, -2. 3 times 0 plus 1, 1. 3 times 1 plus 1, 4. And 3 times 2 plus 1 is 7. So there's our table. Our inputs in through our function, and then we get our outputs. Is that okay? Right, the next thing we're going to look at. Functions. So, based on our function, they can be increasing, going across, like stage horizontal, or they can be decreasing. So, for example, if our function is 3x plus 2, the number in front of x will tell us whether it's increasing or decreasing. So, if it's a positive number, it's going to be increasing. There's our linear function over there. It's going to be increasing because the number in front of x is 3, and 3 is a positive number. Is that okay? So that means it's going to, as you go from left to right, your function is going to be going up. Over here we can see there's no x, isn't there? It's just a number. What's the number? 4. So we can see it's a horizontal line across 4. There's nowhere. It's just flat across. So for example, if that number was 1, it would be a horizontal line across 1. If that number was 5, it would be a horizontal line across 5. Is that okay? So that's the second type. And the third type of function you can come across is a decreasing. So it's a negative linear function. And we know it's going to be negative ever before we look at the graph because that's a -2. Alright, so what we take out of that is, if the number in front of x is positive, it's going to be increasing. So it's going to be going up as you go from left to right. If there's no x there at all, it's just going to be a stationary horizontal line in the number. And if it's a negative number in front of the x, it's going to be decreasing, going down as you go from left to right. So, plotting functions. The whole point of this is plot them on a graph. So that's generally what you're going to have to do. So we look at the following. Plot the following points and function on the graph in the domain between 0 and 3, or 4x minus 2. So, Emer, is this going to be going up or is it going to go down? What's your reckon? Increasing. Look at it. How do you know it's going to be up or going up? 4 is a positive number. So, as we go from left to right here, this is going to be going up. So, we've got to do our table first. We've got to do our inputs, our function, and our outputs. Exactly. So, first one we get is the function of 0. So 0 is your input. 4 times 0 minus 2. What's 4 times 0 minus 2? Minus 2. That's our first point. 0 was our input, minus 2 was our output. This is going to be our what value? Our x value. And this is going to be our? Exactly. Minus 2 is going to be our y value. We get the function of 1, put it through it. 4 times 1 minus 2 is what you get? 2. So our point is 1, 2. We put 1 in, we got 2 out. Function of 2 is 4 times 2 minus 2, which is? 6. So it's 2, and we get 6 out, and the function of 3 is 4 times 3 minus 2, which is 10. So we get 3 and 10. So now we're going to plot these points. Is that alright? So we get a graph. A, B, C, and D. So I'm going to have a graph over here. So we can see our first point is going to be 0 minus 2. So where is 0 minus 2? There. Out to 0 and up to 2. Sorry, there. Sorry, minus 2. 0 minus 2. Where's our next point going to be? On over to 1 and up to 2. There's our second point. Our next point is? Out to 2 and up to 6. And our last point? Out to 3 and up to 10 is there. And then, because it's a linear function, we draw a line through our points. Is that okay? Right. I want you to do the same for me, so I want you to plot the function. So, what I want you to do is example 2, plot the function 5x minus 3 in the domain minus 2 less than or equal to x, between minus 2 and 4. Alright, between minus 2 and 4. So plot the function 5x minus 3 in the domain between minus 2 and 4. How do we know how high up and how low we need to go? So how low do we need to go? And how high up do we need to go? Plus 17. So you're going to need on the full page. I need to leave one space. You want to know. rough sketch of our graph, we know it's up as far as 17, down as far as minus 13, over as far as 4, and over here as far as minus 2. So, if we look at it then, input function and output, our input is minus 2, minus 1, 0, 1, 2, 3, and 4. Our function then was 5x minus 3. So that's 5 times minus 2 minus 3, which is what? Minus 13. 5 times minus 1 minus 3, which is minus 8. 5 times 0 minus 3, which is minus. 5 times 2 minus 3, which is 2. 5 times 3 minus 3, which is, and 5 times 4 minus 3, which is 20 minus 3 is, are these right? 5 times 2 is 10. 5 times 0 minus 3 is minus 3. 5 times 2 is 10. 10 minus 3 is 7. Am I missing one? Oh, I'm missing one. I put in a wrong number. There we go. I was wondering what was going wrong there. 5 times 1 minus 3, which is 5 times 2 minus 3, which is 5 times 3 minus 3, which is 12, and 5 times 4 minus 3, which is 17. So there are points. 2 minus 13, minus 1 minus 8, 0 minus 3, 1 and 2, 2 and 7, and 3 and 12. Minus 2 is good girl, thank you, and it's 4 and 17. Right, so that is the long way to do it. There's a shorter way, an awful lot of teachers don't show it, and there's your graph. That's what your graph should look like. There's your minus 4, there's your minus 2, minus 13, there's your minus 1, minus 8, there's your 0, minus 3, 1, 2, 2, 7, 3, 12, and 4, 17. There's all your points up there. Now, there is an easier way to do it, a quicker way even. So an awful lot of teachers don't show it. You can do it all in your calculator. Well, you can do it all in that calculator. So, the sharp, I think you might be able to do it, but till you go and shoot or crap calculator, this does not work, especially when you move into the instant level. So, first things first. Hit mode and then 3. So press mode. Mode. And then 3 for tail. You have fx in front of you, so we want to put in 4x minus 2. So you hit 4, then press alpha, and you want to hit this. The alpha gives you all the references, is that right? X, and then you're going to hit minus 2 and then equals then. Minus 2, and then hit equals. Where does our function start? Looking up where we're going. No, where does this one start? Starts at 0. So we press 0, and then equals. And where does it end? We press 3 and equals. Oh yeah, so now this one's set. We have step in front of us now, alright. Step is what are our numbers 1 up to 3? So what are we going up? Whoa, this way. Wait, so go. What are we going up? How are we going to get from 0 to 3? So we're going up in 1. So 1 and then equals. And now we have all our points in front of us. We should have all our points in front of us. So we should have 0 minus 2. So you don't count these. These are your x values. These are your y values. Yeah, so you 0. You start with 1 instead of 0. Alright? So we're going to do another one of these. Is that okay? So I want you to use on the calculator, get me the function of x, which is equal to 3x minus 6 in the domain between minus 2 and 5. We're not going to plot it now, I want you to get it on the calculator. So I want you to use the calculator to get me the points for this. You also see. Our function is 3x minus 6. We're starting at minus 2. We're ending at 5. I'll give you one more minute and I'll give a little run through that again. So, are we ready to run through it again? Right, so our function is, on the calculator, get the function 3x minus 6 in the domain between minus 2 and 5. So the very first thing we're going to do, we all have fx in front of us, do we? So we're going to put in 3, press alpha, and then press to get our x button. I want that red alpha. That one. Minus 6. Right, where are we starting? Okay, equals to enter. Where are we starting? So we put minus 2. We hit equals. Where are we ending? No, just 5. So we hit 5 and equals. And what are we going up in? Ones. Exactly, we're going up in ones. So our points then should be minus 2 and minus 12. It should be minus 1 and minus 9. It should be 0 and minus 5. It should be 1. Sorry, 0 and minus 6. Can't read me on calculator. 0 and minus 6. 1 and minus 3. 2 and 0. 3 and 3. 4 and 6. And 5 and 9. Is that okay? So, when a question like this comes up in the exam paper, you don't actually have to do out all the maths in it. You can do it all in your calculator, but you must write down all these. You must put these points on the sheet of paper so that they can check it. Is that okay? You don't need to show your work. Your teacher will probably tell you need to, but some of these are very, very big and take you forever to get through them, so you're probably nearly better off. You're better off knowing how to use the calculator. And this calculator is the best one to use it with. Also, if you forget that, which I'm sure you might, the steps are there, and if not, there's a little video. Yeah, see, if your teacher wants you to do the table, you have to do the table. If not, in the exams, you don't need to do the table. So there's a little video if you want to recap on any of that. Is that all right? Right. They are linear functions. So at junior cert level, we have linear and we have quadratic. So a linear function is when the highest power is only an x. Is that okay? So the highest power is an x. Quadratics have what? X squared, exactly. And with quadratics, we have two. We have an N shape and we have a U shape. So there are two quadratics. You have your N shaped one and you have your U shaped one. Now, this is nearly the exact same. If you look at our N shaped one, it's minus 3x squared plus 2x plus 4. If you look at our U shaped one, it's 3x squared plus 2x plus 4. What is the only difference between our U and our N? Looking at the function. Exactly. The minus 3 in the N-shaped one and the U-shaped one is just a 3. It's like our linear functions. Remember, linears go up and go down? The N-shaped one, if it's a minus number in front of the x squared, it's going to be N-shaped. If it's a positive number, it's going to be positive. So the way you remember it, if it's negative, it's N for negative. Does that make sense? N for negative. If it's a positive number, it's positive. There's an imaginary U inside the word positive. If you spell it the way I spell it. Alright? So, N shape for negative, positive. So, they are two different things. Right, what I want us to do next then is, before we move on to that, I want us to draw the following. Alright, so I want us to graph the following. This is going to be a quadratic. So I want to graph x squared minus x minus 2 minus 2, less than or equal to x, less than or equal to 3. So, for the first one, I want you to do the table because as far as I know, the teachers in your school make you do the table. Is that okay? And then the next one we're going to do, we're just going to do the pie chart. Is that okay? So I want you to do the table for this one. Yep, plotted as well. Just to make sure we all have the right points before we go plotting. Are we getting minus 2, 4?
Yeah.
Minus 1, 0? Yeah. 0 minus 2? Yeah. 1 minus 2? Yeah.
What was the first one? Minus 2, minus 6.
Minus 2, 4. Minus 2, 4. Right, I'll do the points out with you just before we go plotting, so just make sure we're right. So, our inputs our function and then our output. So our inputs are minus 2, minus 1, 0, 1, 2, and 3. Our function is x squared minus x minus 2. So that is minus 2 to be squared, minus times minus 2, and then minus 2. Oh, it's on freeze. Is that okay? So you literally put that into your calculator. So bracket minus 2 to be squared, minus bracket minus 2, minus 2, and we're getting out 4. Is that okay? The next one is minus 1. So it's minus 1 to be squared, minus minus 1, minus 2. And we're getting out what there? We're getting out 0. The next one is 0 to be squared, minus 0, minus 2. And we're getting out? Minus 2. We're putting in 1 to be squared, minus 1, minus 2, and this time we're getting minus 2. We're putting in 2 to be squared, minus 2, minus 2, which is 0. And we're putting in 3 to be squared, minus times 3, minus 2, which is 4. So our points is minus 2, 4, minus 1, 0, 0 minus 2, 1 minus 2, 2 and 0, and 3 and 4. Can we see how it's way easier to make a mistake when you do it out the table, isn't it? It's way handy if you do it on the calculator. So we're going to plot these points then. Minus 2, 4. Out to minus 2 and up to 4. There's your first one. Our next point is minus 1, 0. Out to minus 1. Up to 0. Our next one is 0 minus 2. Out to 0. Down to minus 2. Our next one is 1 minus 2. So out to 1. Down to minus 2. Our next one is 2, 0, out to 2, and you leave it on 0. And our next one is 3, 4, out to 3, and up to 4. And we can see that's what shape then? U. No, don't do it like a V. You lose marks. They take marks off you in the exam papers if you don't curve the bottom, and that is a fact. Is that okay? Don't do a V. If you do this, they take marks off. Because it's not a V-shaped curve, it's a U-shaped curve. Very important. There you go. Is that okay? Right. I'm going to get you another one now, but you can do it on the calculator and just write down the points. Is that right? So I want you to graph the following. And we're nearly there, guys. Only 15 minutes left. Example 5. Graph x squared plus 3x minus 2 in the domain, means in the input, our inputs are going to be minus 5 less than or equal to x less than or equal to 2. So graph x squared plus 3x minus 2 in the domain, minus 5 and 2. What's your first point, Julian? Minus 5, yeah, perfect. That's right. So when you come up in the exam papers, you don't have to show your work, but if you're doing this like a Christmas test or an Easter test, your teacher might ask you to do it out the table. This is X. That's your Y. These are all your X values and Y values. That's perfect. Always make sure you hit the low. They always give you 2 points and they have the same one. So always make sure you hit the low back. Two perfect graphs, well done. So let's just confirm our points. Our first point is minus 5, 8, minus 4, 2, minus 3, minus 2, minus 2, minus 4, minus 1, minus 4, 0, minus 2, 1, 2, and 2, 8. So, minus 5, 8, minus 4, 2, minus 3, minus 2, minus 2, minus 4, minus 1, minus 4, 0, minus 2, 1, 2, and 2, 8. Once again, hopefully better instead your hands than me. Little dip, make sure you put it in it, and then curve back up again. they dock you 2 or 3 marks if you don't put the diff. Because they want to emphasize it's a U. And also it's very important because we're going to be answering. They ask you questions on this now, so we're going to answer a few questions on this for the last 10 minutes. Is that right? So, that's brilliant. So, as I said, linear and quadratic. They could ask you to do the table. If they don't, straight into the calculator. Is that right? And as I said, you might forget that the video is up online and also the slides are up there. The little videos there. Is that okay? Perfect. Right. Let's look at the next thing. So, with quadratic graphs, you don't have to worry too much about the third one, but the first two is very important that we know what's going on. So, in our first one, the graph intersects the x-axis twice. So, it has 2 real roots. Now, what we're doing right now is very, very related to the minus b formula and the guiding that we were doing. Alright, so for example, if you take our last one, what's the last one we said? X squared plus 3x minus 2, is it? Right. If we do the minus b formula on this, what we're actually doing with this is we're seeing where this function intersects our x-axis. So watch this. As I said, even all these videos are up in the open and look at. Is that okay? So guide number is minus 2. Add to give us 3 minus 1 minus 2. X squared. You just do graphically in school. Is that right? X squared minus 1x minus 2x minus 2 is equal to 0. X times x minus 1 minus 2 times x minus 1 is equal to 0. That's x minus 2 by x minus 1 is equal to 0. Line down the middle, x equals 2 and x equals 1. So if we look at our last one that we did, x squared plus 3x minus 2, and we did the minus b formula and that to solve it, or if we factorize it to solve it, we get 2 answers, 2 and 1. Look down your graphs, where do they run through the x-axis? They should run through at minus 2 and 1. Your scale is really small enough. Yeah, it should run through it at minus 2 and it should run back up through it at 1. So if you did your graphs exactly to the scale, on scale paper, on square paper, it'll run through it at, you sure it's x squared plus 3x minus 2? In fact, why is that wrong? There, 2 seconds. One minute. Bit of a problem here. X squared plus 3x minus 2. X squared plus 3x, yeah? Minus. That doesn't give us plus 3. No. Yeah, that's not going to work. Right. 2 seconds. If we say, for example, x squared minus 2x minus 8. Right, so take x squared minus 2x minus 8. Is that right? We take x squared minus 2x minus 8. We do guide number on this, or do minus b, we're going to get out minus 8, add to give us minus 2, so we're going to get minus 4 plus 2. X squared minus 4x plus 2x minus 8 equals 0. Together come to x minus 4, together come to 2, x minus 4 is equal to 0, x plus 2, x minus 4 is equal to 0, line down the middle, x equals minus 2, x is equal to 4. Alright? So x squared minus 2x minus 8. Now if we look up here, minus 2x minus 8. Turn off that. Where does our function run through our x-axis? Minus 2 and 4. That's the whole point of the minus b formula and factorizing inside. What you're actually doing is, after us plotting our functions, that tells us where it runs through the x-axis. And that's the whole point. That's why they're known as the roots of the equation. Is that okay? So, what we looked at there, so you x squared minus 2x minus 8 on the board. If you solve that using the minus b formula or guide number, you get minus 2 and 4. And what you're actually doing when you solve it is you're figuring out where your function runs through the x-axis. So if we go back to our diagram that we were just looking at. In our first one, we can see it goes down through the x-axis and runs back up, and our notes say that the graph intersects the x-axis twice, therefore it has two real roots. What that means is it has two separate roots, like in our example, minus 2 and 4. Now this one, very important because this comes up. What happens to our graph in the middle one? The curve hits the x-axis only in one spot. What that means is the graph has equal real roots. What I mean by that is, if you look at the following, we're going to take the example this time. So the example we're going to take this time is x squared minus 6x plus 9 is equal to 0. Is that right? We're going to take this example. So guide number, once again, is 9, and to give us minus 6, we're going to go minus 3 and minus 3. So x squared minus 3x plus 9 is equal to 0. Once again, you can just do minus b on this, you get the same answer. Is that right? X times x minus 3 minus 3 times x minus 3 is equal to 0. X minus 3 by x minus 3 is equal to 0. Line down the middle, x equals 3, x equals 3. What we notice? The roots are the same. And that's what happens in this one here. Alright, for a function like that, where your two roots that you use the minus b formula for, so for example, x squared minus 6x plus 9. When we did the minus b formula factorizing, we got x equals 3 and x equals 3. And we can see from our graph in the middle one that it touches the x-axis in one spot. It has two roots, but they're both the same. Every quadratic has two roots, but they're both the same. And the third one, you don't have to worry about at all. That's leaving cert. But it's just to show you that this doesn't have any roots at all. Because it doesn't hit the x-axis, so it doesn't exist. Free. Alright, that's a leaving cert. Right. What is next? Planning quadratic functions. Get that done. So what, guys? Oh, I'm going to show you the last thing about the. So the x-axis, as I was showing you there, x squared plus 2x minus 15. If I wanted to figure out where this graph intersects the x-axis, how would I do it? I'd either use the minus b formula or guide number, exactly. So you can use guide number or minus b formula, and I can see x is equal to 3 and x is equal to minus 5 when I go through it. And where does my graph intersect the x-axis? At minus 5 and 3. The last thing I'm going to show us before we go, and something they asked us, we're going to go back to this again next week and we're going to revise it, don't worry. Where the graph intersects that's the x-axis. What's the next thing I'm going to show you? The y-axis. And this one is way easier. If you take, for example, 2x squared plus 3x plus 3. Now, if I ask you, Eamon, what is that point right there? Give me the coordinate. Which one comes first? The x1, so it's 0. 0. The x value is 0 and the y value is? Julianne, what's that value right there? That one there? What's that one there? 0, 4. We notice that there. We're naming all those things on that line. What is 0? The coordinate is 0. Which coordinate is always 0? Don't know which coordinate? X. Because x comes first, isn't it? X is always 0 on the y-axis. That's exactly what you do to find where it intersects. So you sub in 0 instead of 2 times 0 to the square plus 3 times 0 leaves you with just 3. And if we look at our graph, it intersects at 3. So there are the two things we learned. With quadratic graphs, if they want us to find out where it intersects the x-axis we use, guide number or minus b fun. If I want to figure out where it intersects the y-axis, sub in 0 for x. But even looking at this, like for example, I know where this one intersects the y-axis straight away. 9, because they're always going to put it here. The last number always is. So it's always going to be the last number. Very rare. Is that okay? And that comes up a little bit. We're going to look at how that comes up the next time. Right, girls? That was brilliant. So you try to get your calculator next there, right? I recommend if you are looking for one, it's that. Casio, alright? Yeah. No, it's the room down there. Yeah, you can usually store here. You can now show me. So, when you should store here? Yeah. And shut the room next door. Alright? No, see you guys. Mike says.
Yeah.
You look good.